First half of Math 30-2 deals with logical reasoning, set theory, permutations, combinations, and probability. The second half of Math 30-2 deals with functions, polynomial functions, exponential functions, logarithmic functions, and sinusoidal functions. So we're going to switch gears today, and we start with a review of polynomial functions. In grade 10, you spend a lot of time dealing with linear functions. Y equals mx plus b, and then the different forms that you can see those in. 11, you deal with quadratic functions, anything that's a degree 2 function and creates a parabola when you sketch it. And then in grade 12, we kind of review the previous ones and also begin to explore cubic functions, which is any function that has a degree 3. So a polynomial function has to have an exponent that is a whole number. We are not going to have fractions or decimals in the place of the exponent. The exponent has to be a whole number. And then your coefficient, so the numbers out front of the variables, have to be real numbers. Basically, they're not going to be imaginary. All right, so just quickly, we're going to do a bit of a review here. So this is grade 9, grade 10, grade 11, and then we're going to go into grade 12. But even in grade 12, they still assess you quite significantly on the quadratics, which is why we spend so much time on it in grade 11. And they also pull in some linear and some constant functions as well. I'm going to color coordinate my chart, so I'm going to set up one grid for each of these, beginning with constant functions. We know if we have a function y equals 2, then we have a horizontal line that crosses the y-axis at 2. Y equals negative 2, again we have a horizontal line that crosses the y-axis at negative 2. So if there's no x in the function, then we have a horizontal line. Linear functions is going to be my second grid here. So this was in grade 10, and remember, y equals mx plus b was one of the forms that we looked at. M being the slope of that function, b being the y-intercept. So if we have something like this, my b value, there's nothing we're adding or subtracting, so my b value is 0, or my y-intercept is 0, and the slope is going to be 1. If I go to sketch that first graph, so I'm going to begin by plotting my y-intercept, which is going to be 0. And because my slope is 1, I'm going to go up 1, over 1, up 1, over 1, up 1, over 1. Or we can also go down 1, 1 to the left, down 1, 1 to the left, down 1, 1 to the left. I'm going to connect those dots with a straight line, and that is my first linear graph. My second one, similarly, I'm going to take a look at this one. I don't have anything I'm adding or subtracting, so I know that my y-intercept is 0, my slope is negative 3. So I'm going to start by plotting my y-intercept. Once that y-intercept is plotted, we're going to go down 1, 2, 3, and 1 to the right, down 1, 2, 3, and 1 to the right, or we can also go up 1, 2, 3, 1 to the left, up 1, 2, 3, 1 to the left. And again, we can connect those with a straight edge, and that is what our second graph will look like. So remember from linear, if we have a positive slope, our graph is rising to the right. If we have a negative slope, our graph is falling to the right. And then my last one, I now have a y-intercept of 1, and again, my slope is going to be positive 1. So I'm going to begin by plotting my y-intercept. Now we're going to be at positive 1, and I'm going up 1, 1 to the right, up 1, 1 to the right, up 1, 1 to the right, or down 1, 1 to the left, down 1, 1 to the left, down 1, 1 to the left. Again, with a straight edge, we're going to connect those. And we also recognize that we have two parallel lines because the slopes are the same in those two functions, making the lines parallel. Moving on to the quadratic functions. So if we were to make a table of values, remember with a quadratic, if I start just with my basic y equals x squared, we can choose any point for x, substitute them into our function, and generate a y value. So if x is negative 2 times negative 2 is positive 4, negative 1 times negative 1 is positive 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. So I'm generating a series of points for the first quadratic function. That gives us our parabola. When x is negative 2, y is positive 4. When x is negative 1, y is positive 1. When x is 0, y is 0. And again, we remember there's an axis of symmetry that goes through that vertex, making the other side a mirror image. We're going to connect this in our U shape. Make sure you don't go straight up and down, because then it's no longer a function. It has to pass the vertical line test. And that is the graph for our first function here. In standard form, for the second one, we recognize that we've got ax squared plus bx plus c. This is our y-intercept, our constant. So we know we have a y-intercept at 3, so we're going to plot that point. And again, you can either graph this on your calculator or you can generate a series of points. I'm just going to put some points in here to get some values. If I put in a 1, let's say for x, 1 squared is 1. Times negative 2 is negative 2. Negative 2 plus 3 is positive 1. So I know that when x is 1, y is 1. So there's a point. I also know the axis of symmetry is going to pass through my vertex. So I'm going to have a mirror image on the other side, but we can try this. Negative 1 squared is also 1. 1 times 2, negative 2 is negative 2. Negative 2 plus 3 is that positive 1. So when x is negative 1, y is also that. And then let's put in a 2. When x is 2, 2 squared is 4. 4 times negative 2 is negative 8. Negative 8 plus 3 is negative 5. So when x is 2, y is negative 5. And again, you can always draw your table of values out, or you can graph it on your calculator. But I know I'm opening down because my a value is negative. My leading coefficient is negative. And then similar for the last one, I know that my y-intercept is 19, which is going to be way off the graph. So I'm just going to kind of guess. We're going to put something up there. And then again, you can always just put this into your calculator, get a few key points, and then from there you can graph that. I grabbed my graphing calculator. I typed in this function right here. And then even though I know my y-intercept is 19, I could always adjust the window. I'm just going to leave it as the standard for right now. We're going to graph this. We know it's going to cross the y-axis somewhere up here. But if we're looking for the vertex, because this is going to come into play with several of the units we're going to do going forward, we're going to go second function trace. Because it opens up, we have a minimum. So we're going to choose number 3. The calculator prompts you, it says, are we to the left? And if you look at the cursor, right now my cursor is at -6 and 106. So I need to go way down. So I'm going to move my cursor to the left. Don't press your up and down arrows. Remember, that takes you off the graph. So we're going to come down here. There we go. So get close to the vertex. I'm going to press enter to say, yes, I'm on the left. We're going to go to the right, and we're going to press enter to say yes. And then again, these two arrows, most of you will have them on the top of your screen. That's the range your calculator is going to look for that vertex in. So it says, do you want me to guess where that is in that range? And we're going to say yes. And our vertex is at 4 and 3. So then going back to the graph here, we're going to say, okay, so 4 and 3, there is our vertex. And once we plot that point, again, we're just going to kind of do a rough sketch. That is what my third parabola is going to look like. All right, and that brings us to grade 12, where we're going to take a look at some cubic functions. These ones are new. They're all degree 3, as you can see. And similar to what we did when we started out with quadratics last year, I'm just going to make a table of values so that we can see what's happening. So if I'm going to go down here, I'll just do y equals x cubed, and we're going to generate some coordinate points here. I'm going to choose values of x, and again, you can choose anything. I just want to keep it fairly close to the origin. If I put in a -3, and remember it goes in brackets, -3 cubed is going to give me -27. That's off my grid, so I'm not going to plot that point. -2 cubed is going to give me -8. That one I can plot. So when x is -2, y is -8. That point would be there. -1 cubed is 1. So when x is -1, y is -1. Sorry. So we're going to put that there. 0 cubed is 0, right on the origin. 1 cubed is 1. So when x is 1, y is 1. 2 cubed is 8. When x is 2, y is 8. And then when you actually graph this, you can check on your calculator. It kind of makes a nice little dip-de-doo through there. And again, remember, you don't ever want to go straight up and down vertical. It's not a function if you have a vertical line. Okay, so just keep that in mind. All right, now my second one I'm going to choose a different color. And we're going to take a look at what would this look like when we go to graph it. And I'm going to do this on the calculator just to speed this up a little bit. So we're going to go into y equals, clear out what was in there, and we're going to go negative 4x to the power of 3. And I'm going to graph that. And again, we're just looking for some key points today. So we can see we're going through the origin. So I'm going to put my point there. And then again, we don't need to be super precise at this point. We're just going to kind of make sure we're not going in a vertical line. Dip-de-doo through there, and there is my second one. And then my third one is going to be that function. So again, I'm going to go into my y equals. We're going to clear out what we have there. And we're going to enter x to the power of 3. And then you're going to have to press your right arrow to come back down again. Plus 4x squared plus x, and you can do this with me, and then minus 6. So graph that, and when we graph that, now I am going to tell you that this negative 6 is our y-intercept, similar to what we did here. In this case, we don't have anything we're adding or subtracting. In both of those, it was 0, hence our y-intercept was 0. So I'm going to plot here, negative 6 is going to be my y-intercept. And then if you take a look, I do have a scale of 1, so we can always find our zeros, but I'm just going to tell you, we have an x-intercept at negative 2. We have another x-intercept here at negative 3. And we have another one at positive 1. So we're just going to kind of follow what's on the calculator. And we're going to go kind of up and then down and then up. Try not to go in a straight line. And there is our final cubic function. There's 3 terms that we need to know when we're dealing with functions. The first one is end behavior. Remember, on a Cartesian plane, where x is positive and y is positive, that's our first quadrant. Moving in a counterclockwise direction, quadrant 2, 3, and 4 are as follows. When we talk about the end behavior of a function, we're looking at what happens as we move from left to right on the Cartesian plane. So for example, on my constant, if I go from left to right, I come in quadrant 2, I go out quadrant 1. Or I come in quadrant 3, I go out quadrant 4. So maybe let's just put these on here. So quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So we're going to make a summary chart on the back here. So I'm going to start kind of one at a time. So if we're dealing with a constant, we can go, if we're above the x-axis, we're going to move from quadrant 2 to quadrant 1. Or if we're below the x-axis, quadrant 3 to quadrant 4. The degree we know already is the largest exponent on the main variable, or the x. So if we look at the constant functions, we don't have an x, so that means constant functions have a degree of 0. So we've got a degree of 0. Domain, again, because we continue infinitely to the left or infinitely to the right, we just say our graph on the x-axis is going to hit every real number. So similar, we have x as an element to the reals. And in this case, it depends on what the number is. So here, when I look at my first graph, y equals 2, well, the only value for y all the way along here is 2. The only value in my second graph for y is negative 2. So whatever that number is, that is your range. My range for this one would just be y is 2, y is negative 2. And then take a look, number of y-intercepts. How many times do we cross the y-axis? Well, we can see we're only ever crossing once with a constant function. and the number of x-intercepts. And again, if you look at this graph will never cross the x-axis, nor will this one. The only time that's going to happen is if we happen to have a graph of y equals 0, which lies right on the x-axis, and in this case, we have an infinite number of x-intercepts. All right, so that deals with end behavior and degree. I'm going to, I skipped over this one. So number of turning points is how many times does the graph turn, basically. So we can see we're not turning at all, so there are 0 turning points. So I apologize, it's kind of clunky going back and forth, but we'll live. Okay, so linear, again, if we have a positive slope, so remember, and maybe I'll just draw this in here. So this is quadrant 1, 2, 3, and 4. Okay, so if we take a look, if the graph is positive, we're always coming in quadrant 3, we're always going out quadrant 1. And it doesn't matter where we start. If I start down here, I come in 3, I go out 1. If I start up here, I'm still going to come in 3 and I'm going to go out 1. Anytime the slope is positive on a linear graph, we are going from quadrant 3 to quadrant 1. Anytime I have a negative slope, I'm coming in quadrant 2 and I'm going out quadrant 4. So this is going to come in quadrant 2 and it's going to go out quadrant 4. And again, remember, it always moves from left to right. Degree, we know linear functions have a degree of 1. We know the domain, and again, you can always go back and take a look up here. So all of these have a 1 on the x variable. That's our highest one. And if we look at the domain, these are all moving. So again, we're looking at where does that graph lie on the x-axis. It's going to continue infinitely this way and infinitely this way. But again, we're covering every number on the y-axis, the range. It's going to continue going up, continue going down. We're going to hit every number on the y-axis for the range. So with a linear graph, and I'm going to keep this in set theory. So we're going to say the domain, x is going to be a real number. The range, y is also going to be an element of the real number system. Linear graphs do not turn. They continue in one direction. So we have no turning points. The y-intercepts, and again, you can even just look at my baby graphs here. We're going to cross the y-axis one time. X-intercepts, we're also going to cross the x-axis one time. And you can go back and look at those other graphs that we did initially too. So I'm going to have 1 and 1. All right, quadratics. If my parabola opens up, then I am coming in quadrant 2. I'm going out quadrant 1. So my end behavior is come in quadrant 2, go out quadrant 1. If I open down, I come in quadrant 3, I go out quadrant 4. My end behavior is quadrant 3 to quadrant 4. And degree of a parabola we know is 2. Domain of a parabola, we spent so much time on this last year. We know it's going to be a real number. Range is a little bit different. It depends on which way we open. So if we look at the first one, if we open up, so if we go here, it's going to be whatever that vertex is and everything greater than that. If I open down, it's going to be whatever that vertex is and anything less than that. So it depends on which way we open. So I'm going to say it's going to be either greater than or equal to the minimum, or it's going to be less than or equal to the maximum. And again, you spent a long time last year on it, so we're just quickly going through this again. Turning points. Parabola turns once. We go down, 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 turn, up, 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 up. Or we go up, 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 turn, down, down, down. So we're going to switch directions one time. Number of y-intercepts, we cross the y-axis one time in both of those cases. And then number of x-intercepts. Now, both of these graphs that I drew happen to have 2 x-intercepts. If I go back and take a look at this one, you can see this parabola here has no x-intercepts. It's never going to cross the x-axis. And this parabola has 1. If the vertex lies on the x-axis, we're going to have 1 x-intercept. So again, going back to last year, with a quadratic, we could have either 0, 1, or 2 x-intercepts. And then the new one is the cubic. And so again, if you take a look, if we have a positive leading coefficient, similar to linear, our graph is rising to the right. We're coming in quadrant 3, we're going out quadrant 1. So I'm moving from quadrant 3 to quadrant 1. If I have a negative leading coefficient, my graph is falling to the right. I'm coming in quadrant 2, I'm going out quadrant 4. So I'm coming in quadrant 2, I'm going out quadrant 4. And again, degree of a cubic is 3, and very similar to linear, this is going to continue all along the x-axis, and it's going to continue all along the y-axis. So we're going to put down the domain is just x is an element of the real number system. My range, y is an element of the real number system. And then I'm going to go back. So number of turning points, I want to actually take a look at these ones that we did here. So as you can see, if I look at my green one, we're going down, and even though the slope is not as steep, we're still going down. I'm never going up. So this green one doesn't actually turn at all. Similar with this blue one, I'm going up. Ever so slightly, I switch directions, but I'm not actually changing directions. So I'm just going up, 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 up. So I don't turn at all there. This purple one, right there, I turn. I'm going up, switch direction, I go down. That's one turning point. I go down, switch direction, and go up. That's a second one. So with a cubic function, you're going to have either 0 turning points or you're going to have 2 turning points. We will never have 1. 1 turning point makes it a parabola, so it's only going to be 0 or 2. The number of y-intercepts and the number of x-intercepts. So if you take a look at these examples here, this green one crosses the y-axis once, crosses once, crosses once. So the number of y-intercepts will always be 1. With an x-intercept, it depends on the graph. So my green one, there's my only x-intercept. My blue one, there's my only x-intercept. But the purple one, I have an x-intercept there, there, and there. And there's also another type that I don't have listed here. So we're going to have 1 y-intercept, but we can have 1, 2, or 3 x-intercepts with a cubic function. All right, so this is a really quick overview of what you did in grade 10, grade 11, and an introduction to a new type of polynomial function, and just kind of refreshing your memory on what is domain and range, what is the degree, number of intercepts, and the new thing is number of turning points and end behavior. To conclude, we're going to pull out a few observations. If we take a look at our chart, there's a lot of similarities between linear functions and cubic functions. Both of them, if we're rising to the right, we have the same end behavior. If we're falling to the right, we have the same end behavior. So keep in mind, those two are very similar. If we take a look at the chart, number of y-intercepts is 1 always. So with a polynomial function, we're always crossing the y-axis 1 time. And then something interesting with the last piece here, if we look at the x-intercepts, so this is a degree 1 function, we have 1 x-intercept. This is a degree 2 function, we have 2 or 1 or 0 x-intercepts. This is a degree 3 function, we have 3 or 2 or 1 x-intercepts. So the number of times that graph crosses the x-axis is always the same as the degree of the function. So we can cross less, but we cannot cross more. And with turning points, you're going to notice a degree 1 function does not turn. A degree 2 function turns once, and a degree 3 function turns twice. It cannot turn at all, but remember, it's not ever going to turn once. That would put it back into a quadratic, which it's not. So here's another tip for you, is the maximum number of turning points is always going to be 1 less than the degree. It can be less in the terms of the cubic, but it won't be more.